Hello, welcome to another Explain video. This video we're going to do is the 2020 independent paper for physics, question 27 worth 4 marks. Now this one's going to be revising Ampere's law or definition of 1 amp, what that means, and how does it link to Newton's third law of motion. So if we have a look, the old definition of the ampere stated, the ampere is that constant current which, if maintained in two straight parallel conductors of infinite length, of negligible circular cross-section and placed 1 meter apart in a vacuum would produce between these conductors a force equal to 2 times 10 to the minus 7 newtons per meter of length. Okay, so that's what we're dealing with here. Essentially what that actually means is if you have two wires and the current is moving in the same direction as each other, the two wires will exert a force onto each other that is roughly at that per 1 meter length. Okay, so let's look at the question here. It says explain how this definition of ampere relates to Newton's third law. So that's part 1 of the question. And then part 2, it says calculate the size of the force between the two parallel current carrying wires. Okay, that's what we have. You can do it in either order, but let's just look at explaining how this definition relates to Newton's third law. Okay, so we know that when we have two parallel current carrying wires, this will cause an attractive force. Okay, this can say from wire 1 to wire 2. Okay, this could be a push or pull towards wire 1 to wire 2. So that essentially, if I try to draw that out, we have wire 1 here and we have wire 2. So in the first scenario we said is wire 1 is going to exert an attractive force on wire 2, so that pushes wire 2 up. Okay, but we also know the opposite is true. Wire 2 will also exert an attraction force onto wire 1. This is going to be equal in magnitude, so this is equal in magnitude. Well, this is equal in magnitude, but in the opposite direction. Okay, so if I tried to draw that out, what does that kind of look like? We have y1, y2. We already established that y1 is going to pull y2 up. So force 1 on 2. So the force of y1 on 2. And then if we have a look in terms of y2, okay, it's going to pull y1 down here. So F force on 1 or force 1 by wire 2, and then we'll call this force on 2 by wire 1. So what we see is this follows Newton's third law. Of equal but opposite reaction and action forces. Okay, in this case, You could say that y1 is the action force and y2 is the reaction force, or you could say it the other way around. It doesn't really matter, but that's what we know, and that's how it's applied to this question. Okay. The next thing we need to do is calculate the size of the force that is being exchanged between the two parallel charge or wires. Now we know that it is a attraction force. If you use your right hand grip rule, let's say on this one here, so if it's parallel, the currents are going in the same direction, okay? So if you use your right hand grip rule, the magnetic field kind of loops around like that. It loops around like that. So if the magnetic field is connecting from one side to another, you can almost assume it's like kind of coming together like an entire pole round like that. So that's how we know it's attraction. Now the formula that I use to calculate this is FL mu naught 2 pi over I1 I2 R. Okay, so let's do our substitutions. We know that the length is um, 0.65 in meters. So if I just swap these around, come down here. So the force, if I rearrange everything, is written like this. Now I know that epsilon naught or mu naught is 4 pi times 10 to the minus 7. So if you substitute that with 2 pi, you're left with 2 times 10 to the minus 7. That's our constant here. We have the two currents, and that is 0.375 amps each, separated by a distance of 13.5 millimeters. So you need to put that into SI units. If it's the same current, obviously you can just square it. And then 13.5 millimeters is, 10 to the minus 3 meters. And then times 0.65 meters there. Put it into your calculator. And we get a value of 1.35416. 1, 2, 3, 4, 5, 6. So minus 6 newtons. If we want to round that off to 3 sig figs, that'll be our answer there. So that's how you do the question. If you have any other questions related to module 2 or module 6, sorry, inquiry 2, there is a little playlist there for you as well.